Hey guys, today we're looking at 2.4, which is going to talk about solutions and applications of right triangles. Now, to solve a right triangle means to find all of the angles in all of the sides in the right triangle. So that means to find every single piece in it. And then just a little bit of notation here. When we're talking about how we label triangles, generally we use the uppercase letters to represent the angles and the lowercase letters to represent the sides. So over here, if I have angle A, that's going to be the uppercase A, and side A would be the lowercase a, and so on for all the other angles and sides. So let's just jump right into it. In example 1, it says solve the right triangle, and it tells us angle A is 34 degrees and 30 minutes, and side C, because it's a lowercase c, is 12.7 inches. Round your side lengths to the nearest tenth and your angle to the nearest minute. So what helps me when I'm going through these is to kind of make a little table over here on the side that lists out all the angles and all the sides so I can see what I know and what I need to figure out. So I'm going to start with angle A is 34 degrees and 30 minutes. Angle B, I don't know yet. I'm going to figure it out, but I don't know it yet. And angle C, if I look, angle C has that nice little box in the corner, which means that angle C is 90 degrees. And of course, angle A is the angle right down here, and angle B is the one up here that I don't know yet. And then let's move on to our side lengths. Side A over here, I don't know yet. Side B, I also don't know yet down here. And side C, I do know, oops, wrong color. Side C is 12.7 inches. So for side C and angle A and angle C, I don't need to do anything, but for angle B, angle or side A and side B, I need to figure out what those are. I'm going to start with the angles. Since I know two of them, it's going to be really easy to find the other ones because I know all the angles in a triangle add up to 180 degrees. So the first thing I'm going to do is find angle B. I'm going to do 180 degrees minus the 90 degrees for angle C minus my 34 degrees and 30 minutes for angle A. When I do that, that's going to give me angle B, which is 55 degrees and 30 minutes. So now I have all my angles, and I just need to try and find the sides that I'm missing. When I'm looking for my sides, this is where my SOHCAHTOA is going to come into play and help me out a little bit. So I'm going to write that over on the side over here. And I'm going to start by kind of looking at what information was given to me in the problem and use that to help me find what I need to find. There is a small chance that you could have made a mistake in finding your angle B. And if that's the case, you don't want to have everything else in the problem be wrong because you made a mistake finding angle B. So you want to use whatever was given to you in the problem. So that means that we're going to use angle A. I'm going to say that that's my theta that I'm going to use when I talk about my SOHCAHTOA. So if that's the case, I can kind of start labeling my sides. Side A over here would be my opposite. Side B down here would be my adjacent. And C is my hypotenuse. C is the side that I know. So that's going to be the side that I kind of base off of when I'm trying to figure out which I'm going to use, sine, cosine, or tangent. If I'm looking at SOHCAHTOA, there is a hypotenuse with the SO part for sine and hypotenuse with the cosine part, but there's not one with my tangent, so that one's probably not going to be super helpful for me here. So I'm going to focus on sine and cosine to help me find those missing sides. So let's start with sine. The SO part is opposite over hypotenuse. Well, we just said our opposite side was side A. So let's use our SOHCAHTOA, specifically SO, to find that opposite side. So I'm going to say the sine of 34 degrees in 30 minutes is equal to my opposite over my hypotenuse. My opposite is side A, and my hypotenuse is that 12.7 inches. From here, to get A by itself, all I really need to do is multiply both sides by 12.7. I'm going to go ahead and do that. So I get that A is equal to 12.7 times the sine of 34 degrees in 30 minutes. And I can plug that into my calculator. When I plug that into my calculator, it spits out 7.1933-ish. It did tell me to round my lengths to the nearest tenth, so I would say that my side A is 7.2 inches. So I found side A. Now I need to go through and find side B. So for side B, instead of from SOHCAHTOA, instead of sine, this is where the cosine is going to be helpful. Cosine has the adjacent over the hypotenuse. And so my adjacent side is the side B that I'm missing. So I'm going to use that to help me find side B. I'm going to come over here and say that the cosine of that same 34 degrees in 30 minutes is equal to, now it's B over 12.7. Now that 12.7, same hypotenuse, that didn't change, but the different trig function and the different value on top of the fraction did change. So from here, I'm going to do the same thing. I'm going to multiply both sides by 12.7. So I get that B is equal to 12.7 times the cosine of 34 degrees in 30 minutes. When I plug that into my calculator, it spits out 10.466-ish, which rounding to the nearest tenth would be 10.5 inches. And then I found all of my angles and all of my sides, so I have solved the right triangle. Okay, let's do another one. So same idea, I'm going to start with what I know and then use that to figure out what I don't know. So I'm going to start with my little table, same thing. Angle A, I don't know yet, so leave that blank. Angle B, also don't know yet, so leave that blank. Angle C, I do know, it's got the nice little box down there, which means angle C is my 90-degree angle for the right triangle. We only know one angle this time. Let's move on to our sides. Side A, I do know. Side A is 29.43 centimeters. Side B, I don't know, so I'm going to put that down there with a blank. And side C, I do know. Side C is 53.58 centimeters. Okay, this time it says to round your side lengths to the nearest tenth and your angles to the nearest minute. So same thing. Let's go through and, excuse me. Let's start with our side lengths this time since I know two of those. And since it is a right triangle, we can use our Pythagorean theorem to help us find our missing side length. So that's going to be the first thing that I do, find that missing side length. I'm going to do my a squared plus my b squared equals my c squared. Okay, I know that a is 29.43 squared. I don't know what b is, so I'm just going to say plus b squared, and it's going to equal my c squared, so my 53.58 squared. Okay, I am going to plug stuff into my calculator, so I'm not actually going to do all of that until the last step, just to kind of save myself from maybe some rounding errors along the way. So what I'm going to do here is I'm going to start by subtracting the 29.43 squared for both sides. I get b squared is equal to 53.58 squared minus 29.43 squared. And then to get b by itself, I just need to square root that. So I can plug that into my calculator. The square root of that 53.58 minus the 29.43 squared. And when I plug that in, I get that b is 44.7737-ish. So if I come over here, I would say 44.77 centimeters. Okay, now to find my missing angles, this is where my trig is going to come in, my SOHCAHTOA is going to come in. So write SOHCAHTOA over here. And this time I'm working backwards to find my angles. So I'm going to think about what I know, what side lengths I know, and how that can help me figure out my angles. So remember, we want to use what was given to us, what was already in the problem. So I'm not going to use that B I just found. I'm going to use the C, which is my hypotenuse. So the C is always the hypotenuse. It's the adjacent and the opposite that change. So I know that I'm going to try and stick with some trig function that has the hypotenuse in it. So once again, probably sine or cosine, probably not tangent here. Now, if I'm trying to find, let's start with angle A. If I have side A, that would be the opposite. So to find angle A, I would use side A being the opposite to help me out. So let's kind of look at what that would look like. I would say that the sine of angle A is equal to, and sine is opposite over hypotenuse, so opposite angle A is that side, the 29.43 over the hypotenuse, the 53.58. And from here, to get A by itself, I'm going to use my inverse trig that we talked about last class period. So I'm going to take the inverse sine, let's do it in orange, of both sides. It's going to cancel out here. So I get that A is equal to the inverse sine of this fraction. And that's what I can plug into my calculator. And I would get that angle A is, and it's going to spit out a decimal. So when I plug this into my calculator, it spits out, hold on, 33.317-ish, but it does say to round your angle to the nearest minute. So I'm going to hit second apps, option 4, to change it to degrees, minutes, seconds, and that will give me 33 degrees and 19 minutes. Okay, then from here, you can do the same thing to help you find B. So once again, thinking about the fact that we have the hypotenuse and we have side A, if I'm looking at angle B, side A is now the adjacent. So now I'm going to use cosine to help me with that one. So I'm going to say that the cosine of B is equal to that same 29.43 over 53.58. And I'm going to do the same inverse trig, but now it's the inverse cosine. So it cancels out here, and I get that B is equal to the inverse cosine of the fraction. Okay, when we look at this one in our calculator, it's going to spit out 56.683-ish. Which when we do our second apps 4, it's going to be 56 degrees, 40 minutes, and 58 seconds, which is going to round that up to 56 degrees and 41 minutes. Because remember, when we're talking about minutes and seconds, there's only 60 of them. So rounding would be 30 or more would round it up. So make sure you remember that. Then we've got all of our angles, all of our sides, and we've solved the right triangle. Now, where this is applicable, you don't necessarily have to find all of the missing parts. You're just going to find certain missing parts. And one of the most common ones is angles of elevation and angles of depression. So we've got that right here. If we've got an angle of elevation, that's going to be like looking up. An angle of depression is looking down. And it says, be careful when interpreting the angle of depression. Both the angles of elevation and the angle of depression are measured between the line of sight and the horizontal line. So be careful when you're looking at it. Let's look at a couple of examples. We've got some nice pretty pictures to help us out. So it says at a point A, 123 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 26 degrees and 40 minutes. Find the height of the flagpole to the nearest whole foot. So we're trying to find A right here, the height of the flagpole. So, like I said, we're not trying to solve all of the triangle, we're just trying to solve for one missing part here. Sometimes you'll have to solve the whole triangle, sometimes you'll just need to find a part. So let's look at what we know. We know angle A, we know it's a right triangle, we can use all our SOHCAHTOA, all that kind of stuff, and we know two sides. So if we're talking about angle A, it's 123 right here, would be the adjacent side. Then side A would be the opposite side. So if I'm looking at my SOHCAHTOA, thinking about adjacent and opposite, I'm going to use tangent because that's the one that has both of those in it. So I'm going to have that the tangent of A, angle A, is equal to the opposite over the adjacent. So the tangent of my 26 degrees and 40 minutes is equal to my opposite, which is A, over my adjacent, which is 123. To get A by itself, I'm going to multiply both sides by 123. So A is equal to 123 tangent of 26 degrees and 40 minutes. I can plug that into my calculator. And remember, it says find the height of the flagpole to the nearest whole foot. So my calculator is going to spit out 61.77-ish. So to the nearest whole foot would be 62 feet. So that one was an angle of elevation because we're looking up at the flagpole. Let's look at an angle of depression 1. Example 4. From the top of a 210-foot cliff, David observes a lighthouse that is 430 feet offshore. Find the angle of depression from the top of the cliff to the base of the lighthouse to the nearest minute. So when I'm looking at this, when we're talking about angle of elevation and angle of depression, remember the top of the cliff where he's standing and the water are going to make two parallel lines on the horizon. So you can make two parallel lines and you have a transversal cutting through them. That means that your angle of depression up here is an alternate interior angle with this angle B down here that is in our triangle. So you probably remember your geometry teachers talking about how you always use the angle down in the bottom of the triangle when you're doing angles of elevation and depression. It's because they're alternate interior angles. So if we find that angle B down there in the triangle, that's going to get us our angle of depression for the top of the cliff. So let's find that angle. If I'm looking, I have this side over here, which is the opposite side. I have this side down here, which is the adjacent side. So once again, when I'm looking at my SOHCAHTOA, I want to look at what has opposite and adjacent in it, which is TOA, tangent, opposite and adjacent. Okay, I'm trying to find the angle, so I'm going to say the tangent of B is equal to, and then I'm going to set up that fraction. My opposite is the 210, and my adjacent is the 430. Now, if I'm trying to find the angle, this is where my inverse trig comes into play. I'm going to take the inverse tangent of both sides. So over here it cancels. Give me B equals the inverse tangent of 210 over 430. I'm going to plug that into my calculator. It's going to spit out a decimal, but remember we need it in the nearest minute. So it gives me 26.0296-ish. If I hit second apps 4, it changes it to 26 degrees, 1 minute, and 46.5 seconds, which is going to round that up to 26 degrees and 2 minutes. So there's my angle measure. Okay, remember when you're rounding degrees and minutes, there's only 60 of them total, 60 minutes, 60 seconds. So your rounding's a little bit different. And I saved the best for last. From a window 28 feet above the street, the angle of elevation to the top of the building across the street is 53 degrees, and the angle of depression to the base of the building is 15 degrees. Find the height of the building across the street to the nearest hundredth. So let's kind of break down some of this. Okay, I'm going to switch to white so you can see me draw on the black building over here. You're standing over here. Ta-da. And you are 28 feet up. Then you are looking across. We'll stick with the gray. You're looking across this way. And the angle of elevation up is 53 degrees. And the angle of depression down is 15 degrees. you need to find the total height of that building over there. So that means you need to find the height here. And you need to find the height here. Now, that blue height is actually pretty easy. You're looking at that gray line going straight across. So if you're 28 feet up, then up to that gray line over there is also going to be 28 feet up. So you've got the bottom part. Now you got to find the top part. But in order to do that, you need more information about the triangles. So first thing is that we do know that over here, zoom in, these are going to make right angles, which means we have right triangles, which means we can use trig to help us out. So what I need, oh, excuse me, what I need to do is I need to find this distance going across so that I can use that to help me find this distance going up. When I do that, then I can add that y, that distance going up, to the 28 feet at the bottom to find the total height of the building. So let's start with that bottom triangle and see if we can use some SOHCAHTOA to help us find that distance across that x. So if I'm looking at that, my angle is 15 degrees. Across from my angle over here would be my opposite side. That x right there is my adjacent side. So if I'm looking at my SOHCAHTOA, I'll write it up here. If I have opposite and adjacent, that means I'm going to use tangent. So I'm going to split it up. Bottom triangle, top triangle. So if I'm looking at the bottom triangle, I'm going to take the tangent of my 15 degrees, and it's going to equal the opposite over the adjacent. So the 28 over the x. Okay, I need to figure out what x is. So I'm going to multiply both sides by x to get it out of the denominator first. Use a different color here. Go with green. So I have x times the tangent of 15 degrees equals 28. And then I'm going to divide to get x by itself. So x equals 28 over the tangent of 15 degrees. And I'm going to pause there. I don't want to necessarily plug it into the calculator yet. Let's look at the top triangle now. And let's use our same trig, SOHCAHTOA, and see if we can get that y part by itself. So I'm going to zoom in again. If I'm looking across from my angle, over here is my opposite. The x, once again, is the adjacent. So if I have opposite and adjacent, I'm going to use tangent again. So I'm going to say the tangent of 53 degrees is equal to, the pen is lagging really badly today, my opposite over my adjacent. So I'm going to say y, and I know what x is, but I'm just going to keep it as x right now because I'm being lazy and I don't want to write out that whole 28 over tangent of 15 degrees over and over and over again. So from here, if I need to get y by itself, all I have to do is multiply both sides by x. So y is going to equal x tangent of 53 degrees. But we just said that x was this, so I'm just going to plug that in for x. So y is going to equal the 28 over the tangent of 15 degrees times the tangent of 53 degrees. And now I'm going to plug it into my calculator. Work smarter, not harder. Save yourself a little bit of rounding error. Save yourself a little bit of work. Don't plug it into the calculator until the very end there. So when I plug all of that into my calculator, I get that y is equal to 138.6728-ish. I need to find the height of the whole building. So all I'm going to do from here is add 28 feet to it. When I do that, I get that the total height is 166.67 feet. Because it did say round. Well, it said round to the nearest hundred. So yeah, that's right. There we go. Okay, that's it for today. Let me know if you guys have any questions. Get started on your practice that goes with this, and y'all have a good day.